Hello everyone. In the previous video, we have seen what is simple harmonic motion and we have derived a simple equation, that is differential equation of SHM. Now we will see what are the different cases of simple harmonic motion. We have three cases. One is free oscillations, second one is damped oscillations, and third one is forced oscillations. One by one we will see now what is free oscillation. To understand the free oscillations, let us consider these examples itself. These are the examples of the SHM. One is simple pendulum and another is the spring. A mass is attached to that. So when I take this sphere to this height and then when I leave it, it oscillates. It oscillates and then stops after some time. This will also, when I pull it down and when we leave it, it makes the oscillation, up and down oscillation, and it stops. Why it stops? It stops. Why it stops? Mainly because of the friction between the medium and then this system. The friction between the medium, that is air medium, and this system. That's why it will stop. So there is a friction involved in this. There is a friction involved in this, or we call it as a resistive force. So it is resisting to oscillate. After some time it will stop. In the free oscillation, we will neglect this. We will consider the ideal condition in which the friction or the resistive force is neglected. When we neglect the frictional force or the resistive force from the examples, what happens is the oscillations will be forever. The time of oscillation is infinite. Those oscillations will run forever. And then amplitude. What is amplitude? Amplitude is the maximum displacement taking place. So till here it goes and then comes back till here. Till here it goes and till here it goes. It makes the oscillation. This is the amplitude, the maximum displacement. The amplitude remains the same. That is a constant amplitude we will get in the free oscillation. Free oscillations are the oscillations in which only the restoring force is present and the time of oscillation is infinite, and in which the amplitude remains the same or remains the constant. Amplitude of the free oscillations are undiminished. Those are not going to diminish. Those will be constant. So these 3 points should include in our definition of free oscillations. This is the graphical representation of the free oscillations, which is a sine wave. So this is crest and trough kind of a thing. This is up and down, up and down, up and down in case of a spring which is loaded with the mass. In case of a simple pendulum, it is the left and right. That is the to and fro motion. Okay, so as we said that this is the undiminished, amplitude is undiminished. So this is the amplitude. So this is undiminished. That means the constant. That means the constant amplitude is constant throughout the oscillations. So here also the amplitude is constant. So this is constant amplitude which we get. And then time of oscillation is infinity. It goes to infinity. Okay, and the equation for the free oscillation is as that of the SHM. That is x is equal to a sine theta, or you can write x is equal to a sine omega t. And the differential equation for this remains the same. That is d square x divided by dt square plus k divided by m x is equal to 0. This is a differential equation, and solution of this is this x is equal to a sine theta. Now, what are the examples of the free oscillations? Here in this free oscillation, we have assumed that the friction is not there. Resistive force we have neglected, so that it will oscillate forever for infinite time of length. But in nature, there are no as such examples which run forever, which has the time length of oscillation infinity. So this is the ideal condition which we have assumed, but in nature no examples are existing. So one or the other way there will be friction. We can reduce the friction, but we cannot make it is equal to 0. So there will be friction with the air and then this system here at this point with the air and then sphere with the air and the string, but we cannot make the friction is equal to 0. But as for the free oscillations are all the examples of the SHM provided neglecting the friction. So simple pendulum, it may be the spring constant or the string or the guitar or the tuning fork, all the examples in which friction is not there. Thank you.